So let's go ahead and solve this equation. When you have two different trigonometric function values in your equation, oftentimes you can replace the squared ones. So we have our Pythagorean identity that secant squared x is equal to tangent squared x plus 1. So we can rearrange that and replace tangent squared x with secant squared x minus 1. So we'll go ahead and replace tangent squared x with secant squared x minus 1. So we have secant squared x minus 1 equals 3/2 secant of x. And now our trig function is just secant, no tangents in there. Well, we do have a fraction though, so let's multiply both sides of the equation by 2 so that we don't have to have fractions. So 2 secant squared x minus 2 equals 3 secant of x. And we'd like to have a 0 on one side of the equation and hopefully factor the other. 2 secant squared x minus 3 secant of x plus, oh no, that's a minus. Minus 2 equals 0. So this will factor like 2x squared minus 3x minus 2. So if you go to factor that, you would get a 2x times a x. And so 2x plus 1 times x minus 2. So this will factor as 2 secant x plus 1 times secant x minus 2. Then we can set each factor equal to 0. So we have the secant of x turns out to be negative 1/2, or the secant of x turns out to be 2. Now I prefer to work with cosine, so I'm going to flip these fractions. So this is the same as cosine of x equaling negative 2 and cosine of x equaling 1/2. Now one of these has an issue. Do any of you see which one has an issue? Okay, the cosine of x is never going to equal negative 2. It always falls between negative 1 and positive 1. Cosine of x, though, could be 1/2, so that would be adjacent over hypotenuse. So let's go ahead and draw a figure here. We would have adjacent over hypotenuse 1 over 2, and that could happen in the fourth quadrant also. So then we get the 1, 2 square roots of 3 right triangles. And that would make our reference angle 60 degrees. Okay, so 60 degrees here, 60 degrees here. So the whole terminal side would land at 300 degrees then. 360 minus 60 is 300. So just convert those to radian measure. When you do that, you'll have a pi over 3 and 5 pi over 3.